Okay, hello guys, welcome to body plot part 2. Remember part 1 we did questions where you are given an equation or a formula and you're asked to draw up a table from that and also plot your body plot. So this time we are doing questions where you actually are given a body plot and you are asked to answer some questions based on that. So let's get started. My name is Jacob Komati, and don't forget to go to my profile, search my name, subscribe, and click on the playlist, and you can just check any subject you want there. Okay, so before we do questions, I want us to go through some basics quick. Remember, this is like exam preparations. It's not an actual lesson. So yeah, but for this, I feel like we should just go through some lessons quick. So from your body plot diagram, the one we'll be doing today, you should know where to find certain values, how to find them. For example, number 1, I have gain and phase values from the graph at any given frequency. So first, let's check the graph. So how is our graphs, how are they presented? You will see. Remember, your body plot is an open loop diagram for gain versus frequency and phase versus frequency. So this is how you find your graphs. Sorry, what happened? Yeah, this is how you find your graphs. If you check on your screen there, I have a gain on my y-axis and my frequency. So this is gain and frequency on one. It's just one plot. Then you have another graph which is phase and frequency. So they can give you graph like this, or they can give you graph like this. You see, with this one, I have gain on this side, on my left side, and phase on my right side. Then your horizontal axis or your x-axis is always frequency. So you see, and your curves are also labeled. This curve on the top, it's gain versus frequency. The one on the bottom, it's phase versus frequency. So I hope you can notice what's happening. So it's either you can be given 2 separate graphs, or you can be given 2 graphs on one axis. So this is how your graphs are. So now back to our point 1. You should be able to read the gain and phase values from the graph. So I'll just go to any graph. Let's say this one. Let's say with this graph you are asked to determine the phase value when frequency is 1. For example, here's frequency 1, so you just go up to the phase to the gain. I mean, if the phase value and frequency is 1, you just go to the phase graph, you check the corresponding phase. Remember, phase is on the right side, and that looks like it's between minus 90 and minus 120, somewhere there. You just calculate properly. You will see when we do questions, everything will make sense. So the same with gain. If they ask you to calculate gain at 10 rad per second, here's 10 rad per second, here's our gain graph. You just go to the right, check, looks like minus 20 decibels. I see. And another thing, they can also ask you to give frequency. Let's say they ask you, give us frequency when gain is 0 decibels. So you go to your gain when it's 0, you come here, you check the corresponding frequency. It looks like it's between 3 and 5, which is 4 rad per second. For phase also, gain when phase is, let's say, minus 90, go to minus 90, it's somewhere there between 0.5 and 0.7. You see, so that's point number 1 and number 2. Now, peak values. So for peak values, in my experience, I've never had them asking for peak phase. It's always peak gain or frequency at peak. If they say frequency at peak, remember you have two frequencies. You have frequency where there is gain, you have frequency where there is phase. So if they say frequency at peak, they are referring to peak of your gain. But in most questions they specify, they say frequency at peak gain. If they say peak gain, they want peak gain. Remember, peak means maximum value. For example, if I go back to this graph, if I'm looking for a peak gain, you see peak gain will be somewhere there where my cursor is. So my peak gain will be somewhere around 35 decibels. Then the frequency at that peak, you just go down with this line. It looks like it's 0.3 rad per second. Okay, let's move quickly. Now we have corner frequencies. This one is very interesting. So guys, with corner frequencies, you are going to actually check for an actual corner on your graph. So corner frequencies, even corner frequencies, they refer to gain, the frequency on your gain graph. So when they say corner, you're going to check whether it's corner on your curve. So if you check this curve I open now, doesn't have a corner. It's just the curve. There's no corner. But there is questions where I have corner. I'll show you. But let me just draw example here quick. So let me just draw this one. Let's say I have a graph like this. Never mind the straight line. Let's say it's gain. With corner frequencies, you'll see usually it'll be like something like this. Then it will take a sharp turn, maybe like this. You see, like it will be visible. You will see it. So when they are looking for corner frequency, they're actually looking where it's taking a corner there. So in this case, I have corner there, corner here, corner here. You will see if you practice all exam papers, you will see. So you just give us the frequency there and rad per second. That's corner frequencies. Now another thing we have is cut-off frequencies. Cut-off frequencies is it's exactly like slope. Remember how to calculate slope, but not slope as in terms of gradient. Slope, you just take the final value minus the initial value. That's your corner frequency. Final minus initial. I will give you. Let's go back to this graph. So guys, with with cut-off frequencies, we have intervals. And they are called decades. We have decades. Remember, decade mean a 10. So we have interval from 0,1 to 10. We have, or from 1 to 10 depending on the question, but they usually say 1 to 10. Then we have 10 to 100. We have 100 to 2000. That's decade. So you must find, if they say, so the question sometimes they specify, they say give us what do we call this again, give us a cut-off frequency between 1 to 10 rad per second. But if the question just says give us cut-off frequencies, they want all these intervals. For example, this question I have here, the first cut-off frequency I have is from 0,1 until 1. Then from 1 until 10, from 10 to 100. So I have 3 corner frequencies. I have corner frequency there. Not corner. Why do I keep on saying corner? Your cut-off frequency. I have cut-off there, cut-off. So for example, my cut-off, also with cut-off, you are going to look at the gain graph. So you're going to look at that value when it's 1 and this value when it's 0. So you say this minus this. So final minus initial. When it's 10, you're going to look at that value minus this value. When it's 100, that value minus this value. That's your and your answer. Let's say let's do from 0.1 to 1. This looks like it's somewhere at 25 decibels. So your answer will be 25 minus, here it looks like it's between 25 and 20, which is 22.5. But let's just say 23 because it's just an example. So your answer is 2 decibels. When you answer it, you're going to say per decade. And you notice when you practice, they usually give two answers. They give answer per decade and answer per octave. Octave means 8. So this one, how to answer in per octave, you just have to research on that. It's your, just research on that. But guys, there's no question where they will ask you give cutoff frequency in octave. They will just say cutoff frequency. So it's up to you to say decade or octave, but the answers are not the same. If this is 2, you find out this is maybe 0.8. It's usually smaller than decade. Yes. Okay, let's move. I want us not to waste time. Now this last ones, number 6 to 10, these are very important. Let's start with gain crossover frequency. Gain crossover frequency is frequency when gain is 0 decibels. Phase crossover frequency, it's frequency when phase is minus 180 degrees. Those 2 points are very important. 0 decibels and minus 180 degrees. Then we have gain margin. Gain margin, I like using a formula which is 0 minus gain. Phase margin, I will use the formula 180 plus theta. So now what is this G? This G, it's gain, where's my eraser? I didn't want this video to be long. Okay, this G is actually gain when phase is minus 180. Then your theta is vice versa also. It's phase when gain is 0 decibels. So let's just go back here quick. I want to show you something very important. Let's say I have 2 graphs. If you want this to be easier for you, let's say I have 2 graphs. I have a gain graph and a phase graph. For let's say this side is phase. Let's say this point is minus 180 because these are the only 2 points I need. This side is 0 decibels. So 0 decibels here, this is where I'm going to get my gain crossover frequency. Then minus 180 somewhere here. Okay, I want minus 180. Let me put it here somewhere like different. Let's say it's here. This is where I'm going to get frequency, my phase crossover frequency, my gain crossover frequency. Now guys, if you want your calculations to be easier, every time after identifying that point, just draw dotted lines to get the corresponding phase. On phase, draw dotted lines to get the corresponding gain. This gain is the G you're going to use on phase margin. This phase is the theta you're going to use on phase margin. G is the one you're going to use on gain margin, because the formula for gain margin is 0 minus G. You can't use this point because that point your G is already 0 decibels. For phase margin, it's 180 plus theta. You can't use this point because this point is already minus 180. So 180 plus minus 180 is 0. So you're going to use this point. I hope that's clear. Okay, yeah. So guys, what are margins? Margins is an amount. Let's say for gain margin is an amount your gain can be shifted by to cause the system to be stable. For the same thing applies with phase. An amount your phase should be shifted by to cause it to be stable. Okay, but usually they don't ask that. I've learned to Never say never. Now guys, stability of the system. This depends on your gain margin and phase margin. If both are positive, then the system is stable. Otherwise, it's unstable or instability. If any can be negative between number 8 and 9, gain margin and phase margin, it's unstable. But if both of them, the answers are positive, then the system is stable. I hope this is clear. Let's try questions. We have, let's start with this one. We have, this is, I think, April 2021 and April 2019. We'll do 2 of those. April 2021 and April 2019. Is this still recording? Okay. Here's my audio. Okay. Alright guys, so yeah. Okay, we have, so the body diagram sheet is attached from 0,1 to 100. Determine from the graph peak gain value. I'll write the answers here. This, guys, this question is like 10 marks every time. It's every question is 1 mark, 1 mark. Then stability, it's 2 marks because they want you to explain your answer. So peak gain value, so they're looking for what? We know they are looking for gain, so our answer must be decibels, but peak means maximum. So we are now going to our graph to check that. So if we check, maximum looks exactly, oh, this is phase. So, and make sure you also check the appropriate graph because they said peak gain value. So maximum looks like it's somewhere close to 45. You see, it doesn't touch 45, but somewhere close to 45. So let's say if this is 30, half of 30 is between 30 and 45, we have 15, so half it's 7,5. so that looks like very close, not half of 7,5. so let's say 43 decibels. Your answer should make sense. You can't say 40 is way below. And when they mark, they are not too strict because it depends on how you see the questions. So this is 43 decibels. Now the phase value at frequency of 80 rad per second. So they gave us frequency 80 and they are looking for phase, which means they are looking for degrees. So let's go. So I'm going down to when frequency is 80. Here is 80 here. I hope we can see it. Here's 80 here. We just go up with it. We meet the phase here. Do you see the phase? It's there. It's between from 240 to 270. We have difference of 30. So if we divide 30 into 1010, it will be 250, 260. Yeah, 250, 260. Yeah, difference of 250, 260. What's the difference here? 30. Yeah, 250. Yeah, it'll be 250 and 2 at 1. So you just divide it nicely. I think that when you divide, it makes your things easy. So we divide it into 2, but it's 30. It's 250 and 260. So this looks like somewhere 250 or just above 248 or something. So let's just stick with 250. But also pay attention. This, your face is always negative. So this is negative 250 degrees. Now the frequency at the peak gain value. Now the frequency at that value of 43 decibels. The frequency, so they're looking for what? Rad per second at peak gain. So we are doing that. So we are going back to our gain. Our gain looks like it's somewhere here. The peak. Because if you check here where it starts, it's at the bottom. So the frequency, yeah, this one was not clear because it's a straight line a bit. So, but the frequency, we can pick anything from, let's say, 0.4, let's say until here, maybe 0.6. So let's just say 0.5, somewhere in the middle. But guys, when they answer this, they are not straight. So this is 0.5, it's frequency, rad per second. Gain cut off. Guys, remember cut off, I said it's slope. Maximum, not maximum, final minus initial. And they gave us, they don't want all the cut-offs this time. They gave us, they said between 1 and 10. So we are going to gain between 1, which is here. So if we check that value, it looks like, remember this is 45. We can divide 45 into what? Into 35 and 40. So this looks like 35. And at 10, it's here. 10 we divided into minus 10 and minus 5, so this looks like minus 10. So minus 10 is the final. Initial it's positive 35, so which means our answer will be minus 10 minus 35, which is minus 45 decibels. You don't have to write the question like the calculation. This is 1 mark. You don't have to show how you got it. But yeah, we got it because we said final value minus 10 minus initial 35. Now, the gain crossover frequency. So, I know this question confuses a lot of people. You don't know, are they looking for gain or frequency? You see, they're actually looking for frequency because they're saying the gain crossover frequency. You see, where there's frequency, they're always looking for frequency. So this is where, this is frequency when gain it's crossing over, which means when gain it's 0 decibels. So let's go to our gain. This is 0, gain is 0 here. What's frequency there? It looks like 8. So our answer is 8 rad per second. Now, phase crossover frequency again. Frequency when phase is minus 180. So when phase is minus 180, let's go and check the frequency. Here's minus 180. The frequency is there. This looks like between 1 and 8. Yeah, between 1 and 8. So we can say, remember this won't be 4 because 4 is between 0 and 8. So this will be, because if we divide between 1 and 8, let me draw here. Between 1 and 8 we have 1, 2, 3, 4, 5, 6, 7, 8. You see, this is 1, 2, 3, 4, 5. So if I have 5 and 4, this is 8. You see, I have 2 here, 2 here, which means it's exactly in the middle of 4 and 5, because this looks like exactly in the middle of 4 and 5 here. So yeah, but I'm sure if you pick 4 or 5 you'll be given, but for me I can see it's not. If this was 0 until 8, I would say 4, but this looks like 4,5. 4,5 rad per second. Guys, gain margin. Remember, gain margin is 0 minus gain. Where do we get this gain? I'm writing the formula so that you can understand. So we have to find this gain. I said this gain is when phase is minus 180, which takes us to, remember, do you see now we don't have two graphs on the same axis? So I must go check when phase was minus 180, frequency was 4,5. So I must go check what is the gain at 4,5. So somewhere here in the middle. So if I go up here, the gain looks like, let's just pick this point. Looks like it's positive 15. So my gain margin will be 0 minus 15, which is negative 15 decibels. You see, because that's 15 already, your system, that's negative already, your system is not stable. Now phase margin, it's 180 plus theta. Now let's go to our gain crossover frequency. We said our gain when it was 0, the frequency was 8 rad per second. So I'm going here. When gain was 0, frequency was 8. So I must go find phase at frequency of 8. So here's phase at frequency of 8. It looks like it says 230, 220. It looks like it's minus 230. So my answer will be feet 180 minus 230, which is minus 50 degrees. Now, last question. The stability of the system in terms of gain and phase. Your answer will be the system is not stable or is unstable because the gain and phase margins are 0. That's what they want. I'm not 0, they are negative. It's not stable or it's unstable because the gain margin and phase margin are negative. It's only stable if both of them are positive, not one positive, one negative. The moment there's any negative, it's unstable. I hope that's clear. Let's do the last one to keep the video short. Okay, next one we have diagram, which is this one. Okay, let me erase these things I wrote first so that there's no confusions. Sorry about that. Yeah, these ones don't matter, but let me just erase them. Okay, sorry about that, guys. Okay, let me change my color to red. Now let's go. First question: the slope of the gain versus frequency response between 1 and 10. You see, this time they use the word slope. Remember, slope is the same as cut off. So we just take final minus initial between 1 and 10. And remember, at gain, this time they told you gain, but when they say cut off, they don't say gain, they just say cut off. So you must know it's gain. So here's our gain graph, the one at the top. Here's frequency of 1 here. At 1, gain is there. It looks like it's exactly 25. At 10, gain is here. It doesn't look like it's exactly on the line, but let's zoom. Yeah, it doesn't look like it's exactly on the line. It looks like it's somewhere there. So if this is minus 15, this will be minus 17.5, maybe 18 and 19. So maybe we can say minus 19. You see? So our answer will be what? Final, which is minus 19 minus 25. That's our slope. Will be minus 19 minus 25. Let's put that in the calculator. Okay, so let me. Today I didn't put my calculator here. I don't know what is this, but it's clearly disturbing me. This thing is really disturbing me. Can I search my calculator? Okay guys, sorry for this. This thing doesn't want to cancel. Okay, but I can find it here. Sorry for a minute. We are almost done. I'm just looking for this calculator. Where are you? Are you telling me my calculator worked for one day? Yeah, this is weird. I had the calculator yesterday. Okay, doesn't matter. I'll use okay, so we said minus 19 minus 25. Let me use my phone. I don't have my calculator with me. So we have minus 19 minus 25. We get, minus 19. Guys, how do you minus 19 minus 25? So we get minus 44. And I think let me just confirm something. Last question, did we have cut off? We had cut off. Yes. Is it that 3.4 we did on last question? You should always name per decade. Maybe some of you remembered, but you couldn't tell me because this is not an actual class, it's a recording. Yeah, but you should always put that per decade. So this one I'm getting minus 44 decibels per decade. Now the slope of the phase, oh yeah, you see, first time I see slope on phase, but at least they specify. But guys, with cut off, it's always gain unless they specify otherwise. If they just say cut off frequency, just know it's gain. That's why, maybe that's another reason they didn't use the word cut off. They decided to use slope. And you see the interval they are using also, but you see it's from 5 to 15. That's per decade. It's difference of 10. So they want that slope from 5 to 15 for phase. So now we are going to phase. This is 5. Phase, it's somewhere here. This is 15. 15, it's this line. And guys, you must check something. This is 10. This is 15. It's not exactly in the middle. You follow these lines. This paper is called a logarithmic something paper 3. I forgot, but you count with these lines. If you check the previous graph we didn't have that line, so we have no choice to say half is there. But if you have those lines, you count with those lines, like this one, which means if this is 0,1, this next line is 0,2, 0,3, 0,4, 5, 0,6. You see, so if this is 1, this line is 2, 3, 4, 5. You see, so between 5 and 15, 15 will be this. So you go to 15, this is phase. Phase at 5, it looks like it's negative. Oh, we check, don't forget, check the proper one. Phase, if this is minus 120. So it looks like it's just above. So we can say minus 118 or something, or 119, because it's at the top of 120. Then here it's exactly on the line. It's minus, it's this point between 210 and 180. 210 and 180 is 200, so it's minus 200. So you'll say what? Final minus initial. So minus 200 minus 18. We get 12. Minus 200 minus 118. We get, what did I do now? See, these phones don't calculate nicely. Oh, is it 118 or we get 8 minus 82, not 12? I don't know why I was thinking we're getting minus 82. Sorry about this, guys. I don't know why these things, and now it's not gone. Oh, it moved. We're getting minus 82 degrees per decade. Now the gain crossover frequency. Remember, frequency when gain is 0 decibels. So let's go. Here's 0 decibels. Here's frequency. Come on. Here it's exactly on this line, which is what? 4 rad per second. This is 4 rad per second. Phase crossover frequency. Frequency when phase is minus 180. So here's minus 180. Your phase, remember, this we have 2 graphs, but remember phase is this one. What's happening? This thing is really against me. Face is this one. Where's minus 180? Is this one. It looks like it's exactly between 10 and 15. So we'll call that 12,5. 12,5 rad per second. The face value at the gain crossover frequency. You see, guys, they are not saying phase margin. They just want to know when gain is 0, what is the phase. They just want that theta we are talking about. Remember, when gain is 0, which is here, go down with it. Phase is this line. Remember that minus 118. That's what they want. So you just write that this is minus 118. So if I calculate phase margin, I will say 180 plus minus 118, because this is that theta. Remember, after identifying gain crossover, you must go to the corresponding point for phase. After identifying phase crossover, you must go to the corresponding point for gain. You see, if you check the next question, they say the value of gain when phase is minus 180, which is this point. When phase is minus 180, gain is here. It's exactly minus 25 decibels. See, now if they asked us to calculate this, gain margin is 0 minus gain. So it's positive, it's 0 minus 25, which is positive 25. You see, from that formula, phase margin is what? It's 180 plus theta, which is 180 plus minus 180, which is what? Is it 52 or 62? I think it's 62. Just put it in your calculator. Me pressing calculator waste time. For you, you can just pause the video and press. For me, because I can't pause, but it's what's happening? It's 62, yes. Now last question, stability. What is stability? It's stable. Then you give a reason. Because phase margin and gain margin are positive. Yeah, guys, and that's all. That's all on it. So yeah. Thank you for your time today. I'll see you again next time when we do other chapters. We are done with body plot. If you missed the first video, part 1, go on my YouTube and go to playlist. You'll see control systems and check for part 1. Goodbye.